Hello everyone, my name is Alex, and welcome to the first episode in a new series that is how to create a 3D game in Java. Now, some of you might know that I've already got a 3D series on my channel, but unfortunately so many people said that I was copying the Kerno, or the Cherno, don't really know how to pronounce his name. I really didn't, because I was actually learning most of my 3D experiences, well, the mathematics for it, from not just livestream, well, Marcus Person's livestream, which I think it's okay to do that, because I'm basically just um, giving you, or handing the experience over to you so that you can make these 3D games. And also, of course, I have figured a lot of things out myself, obviously. So with that, with all that said, let's just jump into it. Now, in the first episode here, we are mostly going to, yes, so this is basically a refreshment of that, or a new 3D series. So with that said, with that being said, whatever, I'm going to create a new Java project, and in this first episode, we're going to set up the framework, and also we are going to get some pixels rendered onto our screens. Now, the project name, I'm gonna name it like 3D. Oh, that's not 3D. 3D. Uh, uh, let's call it U 3er U 3er U 3er 3D. That makes a lot of sense. I'm actually gonna create this project in the JRE6, because the the newer versions is not always supported by people, because there's many people that still haven't updated, even if there's past like 3 years since the JRE7 came. So I'm gonna go for JRE6 and wait for like 10 more years until I stick to JRE7, because JRE8 is out, so I don't really know, but it works for JRE7 as well, or people with only the Java 7 as well, so works just fine. Now we got the U3R U3R 3D, and I'm going to create the first class here. And the first class, now, by naming in Java, normally you want to stick with an uppercase letter when you name classes. I know I've been going through this a lot before, but for the first class, we want to have our main class, or game class, where we can have everything. And I'm actually going to stick for component, and that's going to be the main framework. And I'm going to code this game so that we can simply make it an applet, and we can switch between applets and different kind of things. Now, after everyone said that I was copying the kernel, I was actually going and checked his videos a bit, or well, the first one, or first and the second one, just to see how similar his code were to mine. And in the first or second episode there, I noticed that he was using the canvas to get this working. I'm actually going to use an applet. I'm going to put an applet onto a JFrame, and I'm going to render a buffered image onto that to get the pixels on the screen. So to do this, we're going to need to import a few things, and I'm going to import the Java AWT, and import the Java X Swing, and that's actually going to be it for now. I'm going to import a few more things later. So we're going to code this. We're going to create the constructor for the class. We're going to do a few things, setting sizes, etc. Now this is going to be an applet, which means that we're going to extend this with the applet like this. What this does is basically inheriting everything from the applet. Now I didn't import that. No. Import. Oh my god. I should have. Oh, 1 second. Yeah. So, as I said, I never imported that class. So I'm gonna import the Java applet, or I never import from the Java.applet library. So I'm just gonna import the full thing there, and that's wrong spelled now. Interesting, but component, I spelled it correct, didn't I? Yeah, and you're gonna see that this little thing pops up here. This highlights in yellowish color. These are highlighted because we're going to come to that later. But what we can do is that we can create a public static final long serial version UID and set it like 1L or something like that, and we'll get rid of that thing. Don't really know what it does because I'm not really into. I mean, it works just fine without it, I know, but I think there has something to do with the compilation into, for example, the applet and getting it to work everywhere. I don't even know. Let's let's just set this thing up now. So because it's an applet, we're going to have a public start method, a public void start, obviously. So a start method like this. We're also going to have a public void stop method. We're going to stop the initialize method because we just want to jump right on start. So I'm just going to leave those like that. Also in here, we're going to have our main game loop. So we're going to import the runnable, and the runnable is for a thread. So we're going to have a thread in here, public void run, and we are also going to have our main method. Like this. So whenever the game starts, if in case it's an applet, it will go towards the start method here. In case it's not an applet, implements please. Yeah, so implements there. Sorry for that. Didn't notice that. So in case it's an applet, it is going to go to the start method here. Whenever it stops, it's just going to go here if it's an applet. In case it's not an applet and we're running it as a JFrame, it's going to go here when it starts. And then when it stops, it's basically just going to die. So we're going to think both here. We need to, in case it's not an applet, we want it to go here, but then automatically we're just going to get the applet right while setting this up. So we want to create this object again, like component equals new component, like that. And this is basically our screen, the thing that's going to be attached onto the JFrame, the things we're going to be able to see everything. Now, by then we're also going to need a JFrame. I'm going to call this frame equals new JFrame. And I'm going to do a few things with the JFrame. Now, first of all, I want to add the component, like this component, because it's an applet. That means that we can attach it onto the JFrame, or pretty much any AWT or swing object. And I'm actually going to right click here and show the line numbers so we can actually see the lines, and also go in here in this mode so we have the bars right here instead, like this stuff, compiler or console, I mean. So yeah, after doing that, we're going to pack the frame. And now what this does for people that's new is basically setting it to the size of any component that's inside the JFrame. So it's going to get the perfect size for this object here to fit in the JFrame. And we haven't really set a size yet. So I'm going to set up a few dimensions. So I'm going to create a public static dimension. This is from the AWT library, Java AWT. And this is going to have the size, new dimension, and I'm going to set a size to be like maybe 750. Actually, let's just stick to a regular size that every computer can handle, pretty much 800 times 600. Now, up here, we are not going to make this game an HD game. Well, you can make it an HD game. That's just setting the pixel size to 1, but this is just a neat little way of getting it really nice and easy to change everything, because everything is going to be so mathematical that we can use whatever size we like to for our screens and everything. So here I'm going to create a public static int, which I'm going to call pixel size. And now this pixel size I'm gonna set to 4 or actually 3 to check and see how that looks. 3 is an odd number, so it might look a bit strange. We might have to change it to 4, but this should work. So now this is the size of the screen, of the like real window screen. Like for example, let's say this part here. Uh, you can see like in Eclipse here, this part. Not the framework here, not the frame itself, but the part inside. So, but the real image that we're going to be working with and drawing pixels on is going to have a bit different size, and then we're going to stretch it out. Now I'm trying to show you with my hands, like doing motions and stuff. That's not really going to work, but that's basically going to be the real size that we're drawing stuff on, but then we're just stretching it out in like all directions to get it fit to the screen. So I'm going to create one that I usually call, I create a dimension, I call it pixels, or pixel size. I'm going to call it pixels, or actually just pixel looks better. Equals new dimension, and we're going to set this to size the width. Now this is the width. Should be, looks better if we do get width. Doesn't really matter. We're going to divide it by the pixel size. So it gets the size of 3. Basically every pixel in there is now going to be 3 pixels. Or well, we're going to remove a lot of pixels. We're going to remove. Oh wait. We're going to remove 2 parts of the pixels, 2 parts of 3 of the pixels in this frame or in this screen to get the right amounts of pixels to get a nice big pixel game, retro stylish game. Then we're going to do the size.getHeight, because this is for the height, the dimension. We're going to divide it by pixel size as well, like that. Which didn't really work. Does it give? Do I have to cast them? Yep. Okay, so it probably gave me the results in like, let's see, gave me them in, oh, doubles. Okay, that's clever. So, and the dimension needs to have integers when we create them in the constructor. Now in the constructor here, when we create this object here, first of all in game, the game starts up, it goes to this one, we create this object, then it's going to jump up here to the constructor method here, the constructor. In the constructor we want to set the size. I'm going to type in set preferred size, because this is in the applet, or well, set preferred size, and I'm going to set it to size. I just spelled that terribly wrong, didn't I? So now this applet is created, and it has got the size of the inner window here. And then we are entering it into our frame like that. Then we're packing the frame so that the frame gets the right preferred size, so that we can work with it. Now the next thing to do is to do frame.set default close operation. We're going to do jframe.exit close so it actually exits correctly. We're going to do frame.set title maybe, and this is going to be, don't really remember, oh yeah, yo Thrier alpha question mark smile, forget about the smiley. And we're also going to do a few more things, I guess. Going to do frame.set location relative to, going to set it to null, which is going to center align the current frame that we're working with, so it will be in the center of our screens when you start the game. And set the visibility. Set visible. I'm pretty sure I forgot something. Normally do. So now we've basically set up the frame. The frame itself should be alright, and we want to run it as a Java application when we run it, like that. Yeah, and here we have this. Oh, I'm gonna get so annoyed of the frame getting in the center of my screen, but not in the recording sized screen. I have to move it down every time. Doesn't really matter, but I'll actually make this a bit smaller to make it fit the recording a bit better. You can just keep your old size. uh, 530 maybe. Yeah, that's better. Looks a bit neater. So now after doing that, we would actually like this to jump over to our start method to start the loop. So we're going to do component dot start. Now this is going to jump up to the start method here, and in the start method, this method will get called uh, either or either. Well, either you say either or either you say either, whatever. Um, but it jumps up to the start method. Well, if you start the game normally, it will go through both the constructor and the start here. So the size will always be set even if it is an applet, which is very nice. So we're also gonna now we're gonna create a boolean. Now booleans, for those of you who know, has a true or false condition. Oh, and also one quick thing about these dimensions before I go to the booleans. The dimension is a width and a height basically, and we are setting the size to width and height. Just an easy way of doing it instead of typing actual 750 or 530 or with variables. So you can see it must have dimension actually. Yeah. Yep. So that's it. So public static boolean is running equals false, and yeah, and whenever the game starts, in case we add some extra code, so we'll have to we go through methods and again, just gonna set it to true here, and then we're going to create a new thread from this object, from this class here, the runnable, this runnable. So the thread is basically this one here, this, and we're going to start it straight away after creating it, instead of having to make a thread and then separate row type dot start. That's just annoying basically. And whenever the game stops now, can actually come to that later, but it's basically going to be is running equals to false, and I'll tell you what that does later. Now for the public void run, we are going to have a while loop, the game loop as it's called, and in here we're going to have the game running, and we are going to type in while is running. When you just type in is running, it means is running. While is running is equal to true, put a little exclamation mark here, it means while is not running. So while is running equals to false, is equal to false. And you can of course do this like normally you would do, typing like equal sign false, or it's not equal to false, or it's not equal to true, and etc etc etc. Now this loop is gonna go really fast. Let's just try it out and see if it works first before I go any further. Hello world. That's a nice little invention there, I guess. Yeah, it says hello world. That means that we got the loop running. But as you can see, whenever I start up this game, it gets a lot of lag, and it's so annoying. Like, yeah. So a game cannot go that fast. That's not going to work. So because this is just printing as quick as the computer can, just taking over everything. It just does its best, focusing on printing hello world to me. Wow. Nice computer. So we're gonna have to sleep it to make it sleep for a little while or stop for a little while every time it goes through this loop. So we're going to do a try and catch because you need it in order to do it or asleep. You're gonna catch it for exceptions basically, if there are any exceptions or errors. I'm just gonna do it like that. You can of course go down the road like that, and you can print some more stuff like e.print stack trace or something like that. But we're just gonna do it like this, and we're going to do thread.sleep. We're going to sleep the whole thread of the game, so we can have multiple threads, and we don't have to worry about sleeping them because they will already be set to the correct sleeping point. So it doesn't cause any extra lag. Now I'm gonna set a sleep to 5. I used to have it to 2, but then I realized that no, that's not going to work. 5, it will be 5. It's 10 divided by 2. Well, 5 times 2 is equal to 10, for those of you who didn't know. I guess everybody knew that. Now if I run it, well, you're probably not going to notice much difference, but in the game you're going to see that it runs a lot smoother. Now in case this is an applet, for example, whenever you exit the game, it goes to the stop method, which gets the isRun equals false, means that it jumps out of the while loop. We can also create cool exit buttons with this, but you can also use, instead of having this, you could just use the regular system.exit 0, which would just exit the game straight away and kill all the threads that were in the game. So that's that part. Now, after setting up the screen, we still can't see anything on the screen. It's just a boring white screen. Well, we got the game loop and all that, but that's not enough. We want some more stuff going on here. We want some stuff happening on the screen. The way we can do that is that we can create 2 more methods here. I'm going to create the public void tick method and the public void render method. This is how basically I set up any game, but we got the render method like that, and this is going to take, let's just give it like that, or do it like this. So we got the tick method. Now the tick is handling things like physics in the game, like for example the character movement. When he's moving, when you're holding down a control, it checks every time, and he moves the character over a pixel. The render, it's rendering things onto the screen. So for those of you who are very new to this, just jumping on 3D straight away, which I highly don't really recommend you to do, but it would probably work. You will probably be able to learn something, I guess. Now the render method here then is for drawing things on the screen. So basically drawing maybe a square, rendering our 3D stuff, and etc, etc, etc. Now we're gonna have a lot of things in the tick method, but also a bit in the render. We're gonna create a few more classes soon, but for the render here, now I usually say tick before render so that it has to do everything before it renders it, so we won't get like after in time. So in here in the while loop, every time it goes through this, it has to do tick and render. This is about every 5 milliseconds, which is pretty fast. Yeah, I know. So now here in the tick method here, so now here in the tick method, we are going to, we're basically going to we're just gonna leave that. Oh wow, that was interesting. The render method, I mean, we're going to set up an image for, and we're going to draw it on the screen every 5 milliseconds, and draw some cool stuff in there, so you can basically kind of see, or we can actually see that everything kind of works. So let's create an image. I'm just going to use an irregular image for this. Public static image. We're going to call this image screen, and this is going to be the image that is the screen. I think this is Java AWT, not mistaken. Yep, this is AWT image. And I'm going to define this when the game is started. Now I'm going to define this probably about, I think this is going to work very well for an applet, but we're going to check it later so I know where to look if this doesn't work. But public void init, this is also a method inherited by the applet, and the init stands for initialize, if I'm not mistaken. And we should be able to initialize this image in here. So screen equals create volatile image, and this is an image that's directly hooked up to your graphics card, and we're going to create it with the dimensions. Now here the pixel come in, pixel dot get width and pixel dot get height. cast them over to ints from doubles, like that. We got the pixel get width and get height. So we're creating an image, a blank image from the dimensions get pixel and pixel height, pixel width and pixel height. Now, right after this, we've already got the image, and the create volatile image is, by the way, a method from the applet here. So yeah, and with the volatile image, we're basically going to draw things on the volatile image. So we're going to draw another image later on top of the volatile image to get the rest of the things going. The volatile image itself is for holding the screen, the playable screen, the inventory. We're going to have like an inventory or something like that. Different things, health bars, whatever type of game you make. So inside the render method here, we are going to create a graphics G object, and we're going to set it equal to the screen image dot get graphics. So now this graphics object is hooked up onto the screen image here. So using this G object here, now we can draw things on the screen. Now let's set a color. G dot set color. I'm going to use my favorite color here in game development. 255, 100, 100 red, 255, green 100, and blue 100. We're going to do a fill rect, and we're going to set it on 10, 10, do the width and the height 200s here. And most of you game developers out there know most of the things I've done so far, but for new people to Java, I'm just trying to go through all the basics as well. Now also we are going to do g.dispose here. We're going to dispose the G object, and then we're going to do a g.g and change the equal sign. Set G equal to get graphics. We're getting it from the applet, so we're going to be able to draw on top of the applet now, and we're going to do g.draw image. And we're going to draw the screen on here, 0, 0, and now we're going to stretch it out. So do size dot get width, cast it to an integer. Don't forget that. Why does it do this to me? So we're going to cast it to an integer here. Same with this one, int, and we're going to do get height. And just gonna go for null. Don't need anything more. Don't need an image observer. But then we got the screen, and we're drawing it on top of here. So we're gonna dispose the G object again because we don't need it, and we're going to go for a test run. Okay, null pointer exception. I probably did something wrong. Yeah, I did, because we haven't. Now this is not an applet, so it won't call the initialize method by itself. We're gonna have to call it down here as well. Component.init, like that. And now we have got an image. Now notice here, normally when you draw a square or a rectangle in this game development stuff or in Java, 100 by 100 is not this big. It's actually like because if I just change the pixel size here to 1, the size will be like that. So that's normal 100 by 100 square. We can even go for like 6 for each pixel. So basically each pixel here is now 6 pixels, which is really big. I'm gonna go for 3. And yeah, that's basically that. Now, this is not the game itself. Obviously not. The game cannot be a square. So I'm going to create another class that will handle the game itself, and I'm going to call this class game, because this is the game itself, the world, basically the room that you walk in, the everything. So probably a better naming invention would be like room instead. And oh yeah, by the way, I do play The Sims. Yeah, I do. if you've, in case you've seen that already, but I just felt I had to record a tutorial for you guys. So create a public, do the constructor public game. We're going to define things. This class is also going to need a public void, not in it, public void tick, and public void render. And now this is going to take a graphics G object, and this graphics G object is going to be from the first class, so we can draw. It allows us to draw on this image here, even if we're in this class. Now, of course, I need to import java.awt library. We could just do graphics here, like this, of course, but I just like importing the full stuff. Just start, or I don't know what it's really called. Asterisk? I don't know. Asterisk. I don't know. No idea. Anyway, now once we got this set up, we want to render it from here, so we can, every time the loop goes through, we want this class to both render and tick. We're going to create first of all an object of that. We're going to do public static game. Then in the initialize method, we are going to define it, game equals new game, in case we had to give it any extra parameters in here. And every time it goes through the render method, we want to do game.render G with the G object, so we can use this graphics object to render on top of the screen. And same with the tick, but we just want to do game.tick, so you can go through different mathematical things. Well, we're going to do some mathematics in here as well, but yeah, we'll go through that, come to that later. Now, alright, now we're rendering that, but we can't really see anything because we haven't created anything. Now to the last part of this episode, rendering pixels and getting everything to work. And the way we're going to do this is we're going to have a pixel array, an array of pixels, and you probably know what an array is if you know some stuff about programming. Arrays are in all different programming languages. Well, I guess so. They should be. Well, they are. But anyway, an array, for those of you who don't know, is just basically an integer of many integers, or well, not an integer, but a variable or an object containing many variables or objects. Doesn't have to be variables at all, but we're going to create an integer array, and we're going to hook that up onto a buffered image, and we're going to render that buffered image. And then everything we change with the array is going to change the image itself. So for this we are going to need I'm going to make this static as well. And for those of you who don't know what a static does, it basically means if it's both public and static, it's accessible from other classes. If it's private and static, it's not going to be accessible from this class. So yeah, that's basically the main thing about it. But I'm going to make this static so we can change it from the outside. Public static, I'm going to call this pixels, this array, actually int, like that, pixels, equals new int. And we're going to set this to the screen size, and the screen size, actually let's just define it in here so we can get the right screen size. So let's type in pixels equals new int component dot pixel dot get width. Times the pixel.getHeight. Now this is a massive amount of pixels we're going to store in here. We're basically storing all the pixels that would be on this screen, well, on this pixel screen. So let's say it's 750 divided by 3 times 530 divided by 3. So it's, yeah, that's a lot, but yeah. So we can actually just calculate calculate that real quick here by just taking the 750 times 530 and then divide that by 3. Pretty sure. Yeah, so 132,500 pixels. That's what we're rendering onto the screen right now. I'm not really sure if that's the right amount, is it? Pretty sure it is. It should be. Actually, no, No, that can't be the right. I have no idea. I think it is right. You're gonna have to check that out later. I'm just gonna leave like a comment below here, like, "Bruh, you were wrong, Alex." Rah. Okay, so let's carry on here. Now, this array contains a massive amount of pixels, all the pixels on the screen. Screen. We're now going to hook that up onto a different array, and these buffered images are using something called the int RGB or integer RGB array. That's a value that goes from 0 to I think 16,777 17. I'm pretty sure that's right. Yeah. No. 16,777 That's the correct amount. I don't really know. Haven't really thought of that as a number, but that's the number. That's the numbers in the number. That's the numbers in the number. But what we're going to do here is, first of all, we just want to set those pixels to a color, and just for the sake of it, I'm going to randomize those pixels just for some fun. So we're going to import the util library, and we're going to create a for loop. Int x equals 0, x is less than pixels dot length x plus plus. Actually, I'm going to randomize those after creating the buffered image. Int y equals 0, y is less than pixels 0 dot length. Y plus plus. Did I spell anything wrong? Oh, makes sense. So let's actually get those by the the height, the width, and then let's do pixels. Pixels. Oh yeah, so I just did I'm just doing some sort of advanced rendering way here. Let's just go through this. Y times that will be get height. No. Get width plus x. We're going to go through these formulas later for what exactly this does, but it's basically just getting all the pixels right. We could just done a simple for loop with like an x variable or y variable or whatever, and just go through them once. I didn't really think of that because I thought I just created multi-dimensional array, even if I knew I didn't. But let's do the new random dot get int dot next int. We're going to randomize just a free number, and then actually before that we are going to set up a buffered image. Now the buffered image is from the Java import java.awt.image, I believe. Yep, that image. And we are going to have that here, public static buffered image, or maybe screen again, doesn't really matter, game screen, yeah, sure. And now in order to define the screen, we're going to do screen equals like this, data buffer int, and then get the raster of the screen, get raster like this, dot get data buffer, and then on all that we're going to get the data or data. Do we need to import a screen to int? No, thank you. Maybe gonna have to. I think it's under the. Yeah. I have no idea. It's very interesting. Odd. Data buffer int. Because the screen. Oh yeah. Because we're gonna do all this on the pixels. I'm dumb. I didn't really think there. But the pixels, you're gonna set the pixels equal to the, and then get the raster from the screen and make it being equal to the right size. So we'll define the image itself from the buffered image and make it an RGB image. So let's create a new buffered image here, and we're going to set it to the width and the height of our pixels. Yeah. So component dot pixel dot get width and then the same with the height here. Then also specify the type. It's gonna be a type int RGB. I mean. So let's see here, buffered. Like that. So we're creating the buffered image that we're going to draw things onto. We are creating a pixel array, and then we are connecting or hooking the new array, onto the screen. So whatever we do with this array will be changed on the pixels array here. There we go. Interesting. So by that means we're setting the pixels here to random pixels, and then down in the tick we don't want to do anything as of now, and then as last thing for this episode we are going to draw the image out. G.draw image, and we're going to do a screen 0 0. Gonna set it to 100%. No HTML stuff here. Oh, component dot size dot, no, actually dot pixel. Actually we don't need to specify this. Let's just put null. All the other stuff there is just stupid. So now when I run this, we should get random pixels scattered all over the place, and it kind of looks like a retro game like this, actually, like really interesting. Like I see Super Mario's head places, which is kind of funny. But this is how we would render pixels onto the screen. Now we can do interesting things with them. And today next episode we're going to get a 3D perspective, changing from our pixel perspective and just getting 3D little screenish 3D area here, like going like a Carter kind of thing. Not really Carter, but it's basically cutting the center here. Going to get rid of the roof. We're gonna get a nice sky and making it look like we're outside. Kind of want to have this game being outside. Just getting away from all the dungeon crawlers out there, trying to make something a bit different. So I hope you guys enjoyed. Please leave a like and rate this video. Wait, that's the same thing. Please leave a like and rate this video. Interesting. Please leave a comment and rate this video. You don't really need to leave a like, but if you liked it, of course, leave a like, obviously. And don't forget to subscribe if you're not subscribed to my channel. And you can check in the description for some more stuff like donations and stuff. Still don't need to donate either if you don't really like my videos. Well, you don't need to donate anyway. But anyway, I hope you appreciate my work, and don't forget to subscribe. I'll see you next time. Bye.